Okay, so like I said, I'm going to talk about the 7 principles of rich web applications. 7 is completely arbitrary, I swear to God. Just came up with 7. Could have been 8 or could have been 6. 7 though. So user experience, like I was mentioning earlier, has to be the most important thing of everything we do. It doesn't really matter what languages we're using, whether it's JavaScript or Node.js or SpiderMonkey or whatever it is, or what really cool patterns we found out and we implemented, or what the latest flame war on Twitter is about these technologies. None of those things are as important as user experience. So what I'm going to talk about today is why JavaScript is uniquely positioned to provide the best possible user experience, even though I think in many cases it kind of has broken a lot of aspects of the web. So today I want to talk about what things we broke and we should fix, because when we had server-rendered applications that weren't using any JavaScript at all, a lot of behaviors were very well thought through, and we just broke them. And the other part of the presentation will focus on the new opportunities. Now we have JavaScript everywhere. We have frameworks like Socket.io that fix all these inconsistencies and they give us a clean API. So what are those new opportunities that we have now that those APIs are everywhere, or even that browsers these days are auto-updating, right? So if there is a new feature, it's going to be everywhere. So what can we do with those things? Like I said, the first thing that we got to understand is that in our chase for the great single-page applications that are fully written in JavaScript, we broke a lot of things. And we didn't just break it. I'll show you that in certain cases, we just completely destroyed it. Like, the web is unrecognizable. Some of those things that we did is, for example, we render blank pages from the server that load a bunch of scripts and CSS that blocks the page, so it continues to be white until they load, and then they get interpreted, and meanwhile it's still white. We broke the concept of scraping, which was a hugely useful thing, not just for search engine optimization, but any tool that you might want to write. You can't write anymore unless you basically fire up a headless browser. We also broke the concept of server-side testability. So with even just curl and bash, we were able before to get a page and prove that there's something that we were expecting in the HTML. And the one that actually bothers us a lot on a day-to-day basis, I'm sure, is the fact that we broke the back button. It's super broken in the majority of single-page applications. And also, I think we've missed the opportunity to address new responsibilities and new opportunities for improvement. So for example, an example of that would be, now that we have all these single-page applications that are real-time and super responsive, are we addressing the fact that maybe the code changes and we need a way to notify the user? So since we're not refreshing the page all the time with every click, this becomes more of a serious need. Or even the fact that if you're interacting with a backend that could be changing, so the code of the backend could change at any given request, what are we doing to make sure that that backend actually is working in accordance with the code that you're running? So all of these things I'm going to try to summarize in 7 principles. Once you learn these 7 principles, I've basically taught you everything I know. There's nothing left, and I'll retire. So we're going to start with, I think, the most important principle, because it's basically where a web application starts, which is with the server. So my first point, and I think it's important to make this extremely clear, especially for us JavaScript developers, is that server rendering is not a choice. It's not that you decide one day, oh, I'll just write all of this in AngularJS, I'll throw in some jQuery, some Socket.io, done. I don't need a server. I'll just query some API, boom, done. It's just not the case, because I'll show that a server-side rendered app versus a client-side rendered app is just a false dichotomy. We've gone too far to one extent, and the solution is somewhere in between. The solution is a hybrid of those 2 approaches. And what it comes down to, this principle comes down to never render a page with just some tags to load some code later. So the main argument boils down to, in order to have the best possible user experience, it needs to be really fast. Like your application needs to be really, really fast. And on the internet, we know sort of what our limit is. We have a limit of how fast we can transfer data back and forth. And just to give an example of that limit in like real terms, I took this example of what it would take to send a packet back and forth from Stanford to Boston. So let's assume the distance there is like 4,000 kilometers. Now we consider that the speed of light in vacuum is constant and we can't surpass it. Then we consider the friction of basically communicating with the channel being fiber. And now we consider how fast we can move in this territory between these 2 points. And that gives us an ideal latency of 43 milliseconds, which seems like a lot, right? Like to me, that seems like a lot for the theoretical minimum or maximum. And actually, with actual tests, we can see that we're kind of far away from that theoretical limit. So if you, the author of this example just used the utility ping to see what the round trip time of an ICMP packet was. And he concluded that at the time of writing, and he kept it, and he actually kept this pretty up to date, the best possible case scenario was that the latency was going to be within a factor of 2 of that ideal limit. And this article, I recommend that you read it. It's much longer than this example. It's called "Is the Latency Stupid?" And that's exactly what I'm going to be focusing about. Not the stupid part, but the latency part. You can find a link to this presentation here. The idea is that in our chase to create the fastest possible application, our goal will be to minimize round trips. We can't change those unavoidable facts of what the distance is and what the packets, how long they're going to be traveling, but we can do the best possible effort to render our application with the least number of round trips. So in light of this, I think you start to appreciate that like rendering a blank page with a script tag is pretty much not ideal at all. And in fact, if you're going to write an application like that, if you're just going to use that, maybe you're even better off writing a traditional application with like PHP that renders HTML. Most likely, the data that you're interested in will not travel in just one round trip. If we consider how TCP works, there is a phase in which we're handshaking with the server. So we're like spending time handshaking with the server. And then the server starts sending data in segments. And there is a congestion control mechanism in place that ensures that the server and client sort of agree how much data can be sent. So it's a sliding window of how much data it can send, and it starts sending very little data. And this is the interesting part when it comes to thinking about optimization. There's a great presentation about this by Paul Irish. It's called Delivering the Goods, where he specifically mentions how these segments correlate to specific sizes in kilobytes that are basically going to be transferred. And he finds that the sweet spot is basically the first 14 kilobytes of a page. Those 14 kilobytes of a page are the most important when it comes to minimizing latency, because it's our first great opportunity to render something immediately to the user. And if we consider the approach of just making the user wait while a script is being parsed, then you start to understand that like you're missing out on a lot of great opportunities to create a very, very responsive application. So a curious thing I've noticed over time is that there's a lot of people that have never actually moved to creating single-page applications. Like, notably, you guys might be users of websites like Pinboard or Reddit or Hackers. There's a lot of those sites that are very heavy on the server rendering part. And in some of those cases, the websites are so fast that it's hard to conceive that JavaScript could even make them faster in many cases. So for example, if you consider that you have a very fast backend and you have the server near the user. So for example, if it's something somewhat static, you can use CDN and cache it. And then you render something that the user can act on those first 14 kilobytes. then you might definitely conclude, and I think wrongly, and as I'm going to show in the rest of this presentation, you might wrongly conclude that JavaScript is just overkill and single-page apps are a fad from San Francisco to the world, and Angular sucks, and Ember is the worst gift to humanity, and things like that. So a really good example that I found some time ago, and I haven't had an opportunity to reference before, is some guy took Stack Overflow, and he tried to do his best to compress it into 4 kilobytes. And he actually got a result that looks exactly like Stack Overflow. Some of the things he did was, of course, he did a lot of micro optimizations that normally we wouldn't do, but I think it gets the point across of how fast a server-rendered application can be. In this case, like he serves the CSS, some bits of JS that he uses, and all the HTML, all in one packet. And it's very well within that initial TCP window, so you're not wasting any back and forth with a server that, in many cases, you don't know where it is to get any content. If you guys want to try it, it's danielc.com/st4k. It works really, really fast. It's a very good, basically, it's a very good example of showing what you can do once you start looking at optimizing this first crucial part of the communication between server and client. And if you think about how the web was conceived, and we think about the browser and how the browser has actually been evolving, but the platform hasn't really changed in terms of like the rendering, the Chrome for like the history management back and forth, and the refresh button, that has not changed a lot. And links fundamentally work in the same way. So if we think about how the web was conceived, there's a very interesting thread that I found back in 1997. Mark Andreessen was proposing the creation of the image tag, which is really funny to read. It's 1993, and he's like, here's a proposal, image tag, boom. And a huge debate ensues about the merits. Like, some people thought that we didn't need images. Some people thought, well, images are a special form of document embedding, and we should do that through the href, through the anchor and href element. We should reuse it and add a relation tag called embed. So a huge discussion about embedded documents and macro pages ensues, and there's a great conclusion that Mark Andreessen writes, and in fact, he goes on to implement the image tag himself for his own browser that later became Netscape, that later became, Mozilla. And he says that by incurring in many round trips, this idea of embedded documents, which is sort of what we do today, then we're sacrificing a key principle of the web, which was you can get information in a single hop. And when I was mentioning that in many cases we've broken the web, is that principle, we threw it out the window for sure. Not because we added new elements or anything like that, but because we got too content with just the network being there, local host being fast, and just adding and adding and adding, and forgetting about that crucial initial page load. The next principle that I want to talk about is reacting immediately to user input. And this is where JavaScript becomes very, very important for us to leverage, because this is something that essentially you cannot do unless you're running JavaScript on the client. So if we stated that basically our goal is to minimize round trips, masking latency is an incredible opportunity to make your website feel extremely fast and responsive. And the opportunity comes down to being able to do stuff on the page without hitting the network. So with JavaScript, we can sort of like predict that certain things are going to happen, or we can render some things immediately after the user does something without actually hitting the network at all. We can prepare for what's going to happen. So the first point, and I think this is what most of you are probably used to seeing on the web, and this is one of the major things that are attractive about single-page apps. Many times when you try a single-page app, you just know. You just, oh, this app is JavaScript powered. You just know it. You haven't even looked at the profiler, but you just know it. And I think layout adaptation is one of the reasons. So a key example is Google. Used to be a very normal website, but ever since, they decided that as soon as you type a letter, in this case, you type the G, they switch the layout to what the layout is going to be eventually once the results come in. The results are not there yet. They're being processed by the network, but you got that immediate reaction that adapted the layout to what eventually was going to become. Another good example is Facebook. So when you launch Facebook, they populate the page with placeholders. Again, they are doing this without actually receiving anything from the server, and they also take advantage of parallelization. So they first make sure that they populate the newsfeed, which is what you're after. You're after those really funny cat videos and the ice bucket challenges. And once they give you that, they load the ads, because that's how they make money from the ice bucket challenge. Another great example, and this is one of my favorites, is Pinterest. So Pinterest goes a step beyond, and they already know sort of what the size is going to be of the funny cat photos. So they do a much better job than Facebook there, because Facebook kind of shows something that might become bigger or smaller, but Pinterest knows. And they also know what the color of the image is going to be. So they have this really good optimization for basically computing the average color of the image and rendering it before the network comes back with a photo. And as you start doing this with like infinite scrolling, the experience becomes really, really nice. Another example I'd like to give is iPhone. When it first launched, it had latency problems, not related to the network, but latency in the CPU processing. So it was really slow to launch applications and sandbox them and all the things that they did. So what they were encouraging developers to do was to produce a static PNG image, and that was the first thing they would load. Instead of your application, they would launch a static PNG image. And that would allow them to do things like animation. It would allow the user to feel like it's super fast. And then the latency would be masked, in this case, again, for actually running something. Another really good opportunity that we took advantage of extensively at CloudUp, because our goal was to make file sharing the best that it could be, was an immediate file representation, which is another form of input. In this case, if the user intent is to upload, there's unique opportunities to use JavaScript to read the file and do something meaningful with it. So an example of that would be reading the EXIF information of the file, which in many cases contains a thumbnail of the content. So even if the browser is unable to process the content, there might be something in the header of the file that already contains a thumbnail. So if, for example, you're uploading a PNG file, a PSD file like Photoshop, it actually contains in its metadata a thumbnail that with JavaScript you can extract and render directly on the page. And that will create the illusion that the upload is happening faster because you're already rendering the content. If you compare that to the first stage of the web, which was you would trigger an upload and then the page would just remain static and something would happen, to the next stage, which was we sort of rendered a progress bar, we can now render we can not only render the file, we can also pre-process the file. So this is just an example of using an NPM module to read the EXIF metadata in the front end directly. And another great opportunity is client-side thumbnail creation, or straight up rendering the entire file directly from the file system on the page. So the way that we take advantage of that at CloudUp is as soon as you hit the intent to upload, so in that case I drag and drop the file, we render it immediately. We produce a thumbnail on the client side, and then we actually swap it if the user is actually going to share the item or something. And we also display the progress as it comes from the server. And again, these are really important things because it's this perception of speed that we're dealing with here. We're overriding our limits in that case, and we're basically making the user feel something that's sort of an illusion. And a great example of that in the real world that I like to share is something that Steve Souders, another expert on web performance, talks about how at the Houston airport, there used to be a very long wait for baggage claim, which is pretty much like any other airport. And what they decided to do to make the user experience better was to increase the length of the walk towards this area of the airport by 6 times. By increasing the walk, by the time you're there, it's more likely that your bags are going to be there, or at the very least you're going to see bags circling around, and you feel a lot better. So not only does it become faster, you feel a lot less anxious. So imagine applying that to the whole internet. Like, let's just make the whole internet faster. Boom. So another really interesting side effect is that doing a lot of optimistic rendering almost removes the need to render any spinners at all. And maybe in like a few years, we're gonna consider spinners a thing of the past, or something that's very rare, or something that the Ajax or the Web 2.0 popularized, and then we sort of tune it down. There are situations, that said, where the illusion of immediacy is dangerous. So for example, you're making a payment. If I tell you, yeah, payment's good, just go, and then you get evicted from your house because you didn't pay rent. Or logging out. I tell you, yeah, it's good, you're logged out, boom, and then someone else comes and like they're logged into your Reddit account and they're reading all the comments you post there, and you're a troll. You're a secret troll, and they find out. So in those cases, I still think spinners or some sort of actual correlation with how the network is performing, like something telling you like, oh, we're communicating with the server, is useful. But even then, it should still be deferred. And for this, I like to refer to very, very old research, actually, turns out, that Nielsen quotes, that says 0.1 second is the time that it takes, or the threshold at which the user doesn't feel anymore that he's interacting with the data in real time. Like, for example, you're using Excel, and you're editing a cell in the spreadsheet, you're having a connection with the data. Like, you feel like you're editing the thing, and it's because it's so fast. For you, within that threshold, it's the feeling of complete immediacy. Then it turns out that up until 1 second is where most people are not able to tell that there is like some heavy process happening. To them, effectively, it feels like real time. So this is the sweet spot for us not to render any sort of spinner or loading indicator or anything like that, especially for tasks that are not sensitive. If it's under 1 second, we can, after that, show a spinner. And 10 seconds is where like the user actually, his attention span goes somewhere else. And he command tabs to some other website or to World of Warcraft. So that might have actually changed, I think, this is from 1991. I think attention spans are like plummeting. So I would imagine that they pull out their phone 3 seconds in, but that's just my anecdotal opinion. So yeah, this is a very useful research to take in mind whenever you're introducing latency. Keep in mind that under 1 second, it's real time. The third principle, and this is one that I'm passionate about because, like I was saying earlier, is sort of all my work with Socket.io comes down to improving on this, which is making all of our UIs for your application eventually consistent. What this means is that if you have many tabs of your application open, or you're looking at the data from your phone and from a laptop, the representation of that data should be consistent in every device that you're looking at, as long as the network allows for it. And specifically, it refers to the idea that the front end is sort of expecting that there are some events of data changes coming from the server and adapts accordingly. And I personally think this is crucially important now because the data points have increased. So with basically having computers everywhere, on our pockets, on our wrists, on our laptops, and in our houses, there's a greater probability that a certain application will be used, and you'll be contributing data points from many different places. So an example of what we did ourselves is assuming that you're going to use the iPhone version of the website and you decide to upload an image, we can be faster than syncing because we're not going into a queue, like, for example, any like folder syncing application. We push the change directly. And you can see in real time, you can even see the title change in real time because we're assuming that our UI will react to changes in the back end. We are not expecting the user to press a refresh button or anything like that. And a new opportunity that comes with this idea is login or session state synchronization. So it's not just the very data that you're manipulating, but it's also things that have to do with your entire session with that application. And a new opportunity there, for example, is to actually enhance privacy. If we think about the web of old, it was sort of static. You would load your bank account, and then it would be there. There would be a snapshot of the HTML. And if you don't close it, it's there. With the ability to synchronize state, in this case, session state, you can have several tabs open of your application and synchronize what user you're logged in as. What I'm showing here is an example of I'm looking at a public link, and then I log out. You're going to see that even the header reacts to that specific change. So this would be the visitor view of the application. And another actually new responsibility that comes with this is what I call state reconciliation. So you probably have noticed that most applications do not handle reconnections gracefully. A quick test that you can do with this is you close your laptop and you do some stuff on your phone, for example, that alters the data that you were looking at before, and then you come back, open your laptop, ideally you reconnect. Is now the data up to date? Is that now the data consistent with the latest state that the server had? Most likely it's not going to be. And the apps that do handle this use case or this particular case well enough, you're going to notice that in many cases they're using polling, because polling gives you this as a side effect, because you're sort of always bringing the latest state from the server. But you also have to be mindful of the diff size. So something I've come across, and keep in mind this is fabricated. I edited it with the Web Inspector, but it happens sometimes that you leave Twitter open for a very long time, or you disconnected a long time ago. Then when it reconnects, it thinks that it has to download the entire Twitter database. Oh, you have 400 million unread tweets. So you also have to be mindful of doing state reconciliation in a way that also makes sense for the user. For example, in this case, you want to cap how many tweets you want to get, and then you want to probably insert like a load more anchor. So another way of looking at reconnections is if we're going to render state on the server side, like we're going to render HTML on the server side, we can consider that the amount of time that it takes for that HTML to get to the user and the script to be loaded, we can consider that as offline time, because the data might have changed in that amount of time. Like, for example, it takes several seconds for the page to travel, and then it takes some time for the user to load the JavaScript, and then they establish a connection. So the data might have changed, and a reconciliation has to happen. So that's why it's very good to have this capability built into your application. Specifically, if you're going to do a hybrid application that does server rendering and client rendering, the data might have changed on the wire while the page was being messaged. The fourth principle is that we now have a great opportunity with fine-grained control of how we send data back and forth from the application to the server. So the browser traditionally shipped with three fundamental ways of exchanging data. One was you would click somewhere and that would perform a GET request. You would get a bunch of HTML, and the page would be replaced with all that new HTML. The other way would be that you look at a form, you fill it out, you post, and the whole thing gets replaced with the result of that post. So, and then this actually would break history, or would make it not user-friendly, because if you try to press the back button, you get a warning about how you're resending data. So that's a fundamental improvement that single-page applications can make. And finally, the other way that you can exchange data is through simply loading objects or sounds or images. And this was very limited, but it was a model that was sort of easy for us to wrap our heads around, and the browser to like understand, for example, when is the page loaded? Well, the page is loaded when all the HTML loads and all the associated images and styles and the onload event fires. So the first hack to sort of break out of this model of communication actually came with images. So I think the first appearance of asynchronous communication happening within a browser was that you would inject like a tiny pixel-sized image, and this still happens a lot actually, just to track people that are not using JavaScript, for example. Even Google Analytics has one of these. They would do like statistics gathering or traffic gathering or visitor counters of sorts. And then obviously came JavaScript, and with that, we can now automate this process and track users very, very easily. And actually, this way that you're looking at here, I remember like many years ago, any mouse event that you would perform on certain parts of Facebook would actually have this inlined as an attribute on the onMouseOver event. Because this is probably the easiest way of sending data to the server, is to create an image, not embedded, and set a source tag to it. So, of course, then came iframes, and I think the previous presenter was talking about this. One technique for doing asynchronous communication would be to inject an iframe out of the view, post to it, or get it, and then that iframe would load basically a page with a script tag that would summon the parent. And that was like the first way to do AJAX. And then ActiveX object came to basically enable asynchronous communication in Outlook, and later to be replaced with XML HTTP request, which evolved into XML HTTP request 2, gained binary data support, and finally we got server-side events and WebSocket. So with all these new basically data exchange paradigms, we need to keep in mind a few other considerations. One of them is we need connectivity indicators, especially if you have this sort of like self-updating UI. The user is now expecting that new data will come in automatically, so it's your responsibility to show whether the connection is active or not, just because maybe the Wi-Fi is down, or maybe your own application is misfunctioning or is going offline, or you're performing a deployment. So when reactivity is expected, we definitely have to show and make this relevant on the UI. The next opportunity is doing offline storage and data synchronization. So if the user performs a certain action and the UI is saying that it's offline, we can still enable him to do it. And whenever a connection is regained, we can sync. And as a matter of fact, now we have a better tool for doing this, because if the user is altering the page offline, we no longer need your application to be actually open as a tab if you're using the new Service Worker API. So this new API will actually help a lot with this particular new opportunity, which is offline syncing. If there is something in local storage, then there can be this worker that is able to make network requests running on the background of your web browser. And even better, you can also use this for asynchronous tracking. So for example, the analytics example that I gave earlier can be further aided with the Service Worker API. And you can also shim it. So if Service Worker is not there, you can do your best to do it in the lifetime of that specific tab. Another opportunity that I don't see enough of in the web is the concept of automatic retrying when something goes wrong. And it's basically the application's responsibility in many cases to retry on behalf of the user. For example, upon an error 500, which might be transitory, it might be temporary, you want to retry on behalf of the user. Another example is if you lose connection and you reconnect very quickly, you also want to retry within that threshold. And it is to be expected of an app that renders everything optimistically. Like for example, when you're using a chat application, normally chat applications will try to render the message immediately, but it may fail when they're actually trying to send it back to the server. So they need to retry on your behalf, and up to a certain threshold, make it obvious that they couldn't. So you have to like transform the representation of that message again. Finally, another key thing that we can do with basically being aware of the lifetime of the request and data exchange in the front end is detecting session invalidation. In the case that, for example, your session expired, it's important to look at the status codes of the errors that happen in those requests and, for example, handle 403s gracefully. And, for example, rendering a message or the login screen. And finally, if we're going to do optimistic rendering, in-transit data warnings are very important. And Gmail does this very well, for example. If the user is sending we're sending some data on behalf of the user and they decide to quit the page, we need to warn them and to not navigate away. And we can do so with the before unload event. The next principle is, I think, one of the most important as it refers to user experience, which is enhancing history support. So the first great opportunity that I see is what a Medium engineer called fastback, which is the idea that we can cache the representation of the latest page that you navigated to, so that when you go back, we render that immediately. And that requires that your application considers relative movement between history states, as opposed to considering each change in the URL as an absolute thing and re-rendering everything again. I think a lot of client-side applications get this wrong because when you go back, they just trigger a new page load as if it was like a vanilla load, and they will basically request everything again from the network, and that sort of defeats the user expectations because the user, when he goes back, is thinking about seeing something immediately or something that he forgot to check or read or something like that. Another hugely important thing to consider is scroll back memory. When we do this navigation, even if it's immediate or not, we have to have a mechanism for remembering scrolling position or re-rendering the portion of the screen that was relevant to that history change. For example, if you're doing infinite loading, you might not want to cache an immense amount of history, but when you go back, you definitely want to keep in mind where the user clicked. And this is where, if we stick to the old way of creating server-rendered apps, this was not a concern because it was very deterministic in how URLs were working, and going back would always produce the intended result. So that's something we broke. A counterexample of this, for example, is the Twitter infinite feed, where if you go past the loading stage, click any link, I'm going to click on a permalink, go back, boom, something completely different, new network request, etc. Bad, super bad. I love Twitter though, if anyone in the audience is Jack, for example. So local state memory, very important as well. This one you might have experienced when you do things like toggling or ephemeral state changes. You change a page in a certain way that is not going to be persisted to a database. A great example of that is Reddit. You go to a comment thread of a funny photo, like that one. Yes, right there. That's the title. And you collapse a few comments, and you perform some history action. Boom, the comments are, you lost track of where you were. So it's important to keep in mind that there is a local memory to that particular tab as far as history changes go. The next principle, and this one is hugely exciting because I think there's only been recently some progress on this regard, is the idea of code updates. So when we think about satisfying all the other principles, like, okay, we made our application update automatically, we have a reactive UI, you can conceive the idea that a person might have a tab open without refreshing at all for like years. And what's going to happen is that you're not going to be able to refresh your code base. Like, there's not going to be any refresh that triggers the re-evaluation of your scripts. So you absolutely need some mechanism, and there's varying degrees of completeness for this, that notifies the front end of changes in the code base. An example of that would be that you send, for example, a socket.io event, code base updated, and then under certain conditions, for example, like the user scrolls to the very top and doesn't have any form state, then you can tell the user, you can refresh on behalf of the user, and you wouldn't break any expectations. You can also consider the page visibility API. So if the user switches tabs and you send them this notification, you can refresh the page on their behalf. Another important thing that I mentioned in the beginning of the talk was actually you might deploy something to the back end that is incompatible with the current front end. So keep in mind also of having the front end notify the server what code state, let's call it the version, they're running. So something we used to do was, for example, add a header to every request carrying like some identifier that could be the latest Git revision of the code base or something like that, which happens to also be really useful for debugging purposes, to understand sort of what code you were running on the front end when a specific backend problem occurred. But the next exciting thing is we can actually reload the code live. In certain scenarios, it should be possible to replace the code on the fly and not trigger a full reload, and then subsequent events happen with a new code base. And I think it's a good time to start thinking about this because there's new programming paradigms like React.js that abstract away a lot of the problems that you would have dealing with state and inconsistencies when trying to reload code in this way. For those that are not super familiar with it, the concept in React.js and how you write your applications is React takes care of like painting the screen. You just tell it, here's my state. You update the DOM for yourself. So they keep a virtual DOM that they diff with the DOM that basically would result from the changes, and then they decide to batch updates to the actual DOM. And they also take care of handling the events on your behalf. So this means that essentially it's performing like a cheap reload, and it fits this model of updating the code very well. And obviously there might be cases where certain components that you have produce some side effects that are not compatible with this, but certainly we will have the opportunity to do a lot of this in the future that we didn't have until today. And obviously we'll probably want some frameworks to handle this for us. And finally, another one that's interesting for the future is the idea of, now that we have all this in place and now that we have a rich JavaScript code base to improve the experience on the front end, we can use it to do predictive basically behaviors, or just trying to guess what the user is going to do to hit the network. Because obviously we know that the network is the unknown, the big unknown, right? And we want to accelerate that request as soon as possible. So in the case of predicting the eventual user input, I think the most common scenario that Gmail or Facebook do is you hover a button and then they trigger some sort of loading, assuming that you're actually going to click. In fact, the first version of Gmail I remember had an interesting optimization, which was instead of binding click events, they would bind mouse down events. And the UI actually felt really fast. It's just a shame that in many cases you do want to hold and then you regret it, so you do need that behavior. But they had a very interesting optimization there in terms of reducing latency. Obviously, it is the latency between holding down the trackpad and lifting it, but it's something. But another opportunity is actually predicting the trajectory of the mouse input, for example. A very cool JavaScript plugin that came out recently predicts the angle and the trajectory, and then sort of with like an idea of collision detection, they can know where the input is going to be at. Works really well for UI things like triggering menus, but also should work really well for starting cache data before the user actually does something. And that would set the 7 principles. It's something that's been on my mind for a long time. I think if you follow all of this, congratulations, you've built a unicorn. And yeah, that's it. Thank you so much for coming. It's questions, not t-shirts. There's no more t-shirts. If the question is, can I have a t-shirt? No. The answer is no, you can't.
What is the backend of Cloud App region? Is it Node.js?
It's Node.js. That said, it's not exactly a super hybrid app in that not every view is rendered seamlessly, but we have a lot of optimizations. For example, when you go to a Cloud App stream, which we know is going to have a black background, we make it a priority that the body has an inline style, so it is black. So there's a lot of optimizations for that initial like 14 kilobytes, but we could actually do a lot more with that. That's why I said, without the frameworks in place to assist in doing this very easily, it's very challenging to satisfy all these principles. And thus, why I said that you would be building a unicorn. As far as I know today.
Do you know Meteor? Have you ever used it?
Yeah, so Meteor introduced some of these concepts, like hot code reloading. I don't know if it works exactly like the proposed React solution works, but they're certainly close to being able to doing that. And a lot of things that they do with as side effects of other things, for example, since they synchronize the entire data set that you request or that you're interested in, then they can do a lot of things optimistically. But that said, since they don't pre-render the view on the back end, in a lot of cases, what you see with Meteor apps is that you're seeing a spinner until the data set that you were interested in loads, and then subsequent actions are very fast. Like, for example, their blog is extremely fast once the whole thing loads. And I'm sure that they can introduce a lot of the optimizations that I mentioned, but certainly they have a lot of freebies that come from this particular architecture, like the database on everywhere approach, and they certainly have a React-style templating engine as well. So since they control the whole thing, and they can actually make a lot of these optimizations.
Perguntas?
The lights are very bright.
Hello. You mentioned that the single page application paradigm avoids the scrapping of pages, correct? How does it do that exactly?
Oh, I was referring specifically to when you don't render anything on the server but a script. The very easy scraping, like you make a request to the page, you're not going to get any HTML that's relevant to that page unless they do server rendering. So that's why I was saying that it is very desirable in many cases to render on the server, because you enable anyone to query your page and then just analyze the HTML. Whereas if you want to do that with an app that's completely front-end driven, what you have to do is orchestrate a browser that then has to actually poll the page to understand when the data is going to be there. Why do I say that? Because if you attach an event on onload, for example, there's actually no guarantee that the data is going to be there, because onload might fire immediately, and they're still rendering on making network calls or something like that. So they made it really complex to extract data out of a system, whereas with vanilla HTTP, it was pretty easy to do before.
Hey, Guillermo. Great talk, as always.
Thanks, man.
You built Cloud Up now a little while ago. If you could start from scratch right now, what would be your dream stack, front to end?
Excellent question. The first thing that I would do is be more mindful of what each page's purpose is. So, for example, if someone shares with you a specific type of link, there's some certain things we can prioritize in how we load that page to give you the content first. Because after all, like, what this is enabling is communication, sharing content. So the top priority should be to display the content as fast as possible. And we don't actually do that in every page. We're sort of, in many pages, relying on what I mentioned earlier about Meteor, where, like, if you have like a ready cache, it's going to be, everything you do is going to be extremely fast. But we didn't pay enough attention, I think, to the scenario where the user has never loaded your site before. So worst case scenario, like, they need to make DNS queries, cloudup.com, they've never been there. I think we're relying too much on loading certain things that we shouldn't do. We should just display the content first. In the Paul Irish presentation that I mentioned, he shows a great video of the mobile website of Imager, imgur.com, where on the mobile side, he's trying to, like, look at a photo of a cat or something like that. And you can see the website loading, and it loads the frame, and it loads the comments, and it loads the title and the styles, and then it loads the photo. And you were there like, I'm coming for the photo, bro, or sister. And yeah, so I think we sort of didn't pay enough attention to that, which seems silly because it's a content sharing website. But we've done a lot of other things really well. For example, when you render a PDF, we render it on the front end, and we have the unlike Chrome, for example, we make a range request to only get the first portion of the PDF, and we load that first page immediately. And we're also making optimizations to, for example, convert it to images for all mobile phones. So there's a ton that we do with the content that's really great. But I think architecture-wise, you always have to keep in mind what purpose you're fulfilling, and also have that be the orchestrator of how you're writing the code.
Mais alguma pergunta?
All right, guys. Thank you so much.